What is log mean temperature difference, LMTD? Imagine you're trying to cool down a hot engine or heat up a cold beverage using a heat exchanger. How do engineers figure out how effective that process will be? That's where the concept of the log mean temperature difference, or LMTD, comes into play. It helps us understand the overall temperature difference driving heat transfer between two fluids that are exchanging heat along a device. In many cooling systems and heat exchangers, the hot fluid enters at one temperature and leaves cooler, while the cold fluid enters colder and warms up as it exits. These temperature differences are not the same at the start and end points. If you just look at the temperature difference at one point, you might not get the full picture of how well heat is transferring. That's why engineers use the LMTD. It gives a single value that represents the average temperature difference over the entire length of the heat exchanger, considering how the temperature differences change along the flow path. The calculation involves taking the temperature difference at the two ends of the heat exchanger. For example, in a counterflow heat exchanger, you might measure the hot fluid's temperature difference at its inlet and the cold fluid's temperature difference at its outlet. The formula then subtracts these two differences and divides by the natural logarithm of their ratio. This natural logarithm helps account for the exponential change in temperature differences along the length, giving a more accurate average than a simple arithmetic mean. Using the LMTD is essential for designing efficient cooling systems. It helps determine the right size of heat exchangers so they transfer the desired amount of heat without wasting space or energy. When the LMTD is larger, it indicates a higher potential for heat transfer, meaning the system can cool or heat more effectively with the same surface area. This makes it a key factor in thermal system analysis, especially for steady-state conditions where temperatures and flow rates stay constant. In practical terms, if you're designing a radiator for a vehicle or a chiller for an industrial process, knowing the LMTD allows you to select the right heat exchanger size and ensure your system works efficiently. It also helps in estimating costs and materials needed, saving time and money during the planning phase. Remember, the LMTD assumes no phase change occurs during heat transfer, so special considerations are needed for systems like condensers or boilers. Overall, understanding and applying the log mean temperature difference helps mechanical engineers create better cooling and heating systems. It ensures that heat exchangers are properly sized, efficient, and reliable, making it a fundamental part of thermal design and analysis.